Hello everyone. In this video, we are going to cover kinematics in one dimension. So we are going to look at different scenarios where we can use kinematics, and let's start with few definitions. So we all know what is the basic definition of distance and displacement. But the important thing here is to remember that distance is the total length the body actually travels, and while the displacement is the distance between the initial position and the final position, that's the shortest path between them. We know that velocity is change in displacement over time, but we also need to know the average velocity, that is total displacement upon total time we have to take. Acceleration is change in velocity, or we can say it as a rate of change of velocity. So those are the very basic definitions. Now, the motion graphs are something that are very much important, and we will start with some distance versus time graphs. So you will see that in the first graph, the distance versus time graph, this is stationary, so you will see a horizontal line. It means the object is at rest. If the object is moving with a constant speed, it will be a straight line passing through origin. Okay. Or it can be, even if it is not passing through origin, it will be, if it is a straight line, it is a constant speed. Then if it is accelerating at a constant acceleration, then the velocity will be increasing. You will see a curve upward. Now, what does that mean exactly? We need to know that in a displacement versus time graph, gradient of that graph gives us the velocity. So in the first example, you will see that the gradient is zero. The gradient is zero. It means the velocity is zero. Here, the gradient is constant. It means the velocity is constant. While in the third example, you will see that the gradient is constantly increasing. So it is an increasing velocity. In other scenario, the gradient can be decreasing. So it can be a decreasing velocity. Okay. And when it gets flat, the velocity will be zero. Since under displacement versus time graph, displacement being a vector quantity, there can be a positive and negative side also. So if the object is moving at a constant velocity in one direction, we can show it like this, and then when it changes its direction, we can indicate by how I showed in the graph, this one, and then it will move with a constant velocity in opposite direction. So in the real, so if this is the original place, if the object is starting from here, so it will move in this direction, let's say, and when the displacement is zero, then it is gone back in this direction. Okay, so these are displacement versus time graph. In velocity versus time graph, we can see that gradient of velocity versus time graph is an acceleration. So if it is a constant velocity, then you will see a flat line indicating that there is no acceleration. If there is a constant acceleration, the gradient would be a constant. So you will see a straight line. And then if it is increasing acceleration, you will see that the gradient will be increasing, while if it is decreasing acceleration, it will be like that. The example of decreasing acceleration is when the object is falling in free fall in air resistance. So what happens? Usually the air resistance keep on increasing as the velocity of the object, but when the air resistance balances out the velocity weight of the object, in that case, the object reaches a terminal velocity. And that's where the graph starts becoming flat, because the terminal velocity is a constant velocity. There is no acceleration at that time. If you can also see, there is one more example of this. So you will see that there is a constant deceleration that is happening because velocity is decreasing, and then at a certain point of time, the velocity will be zero, and then the velocity again start increasing. This happens usually when you throw something up and it comes down. Now, since the gradient is same throughout the straight line, the gravity is an example where the gradient remains constant. Okay. Now, what we need to remember about the various kind of graphs, if it is distance versus time graph, we will get speed. If it is distance versus displacement versus time graph, the gradient will give you velocity. If it is speed versus time graph, gradient can give you acceleration, but magnitude of it only. and the area under the curve will give you distance traveled by the object. If it is velocity versus time graph, if you take the gradient, you will get acceleration and magnitude with direction, while if you take area under the curve, you will get a change in displacement. Now, if you are having acceleration versus time graph, the area under the curve will give you change in velocity. Now, change in velocity is like there is 2 points. So what is the point velocity at that point and minus the velocity of that. So we can write this as final velocity minus initial velocity. That is a change in velocity. Okay. We will also make a use of kinematic equations in one dimension, that is SUAT. So first equation S is equal to U plus V upon 2 into T. Then S is equal to UT plus half AT square, V square, U square. So here U is the initial velocity, V is the final velocity, A is the acceleration, and S is the displacement. Okay, change in displacement is mostly we talk about. Now, remember this. There is one more thing that we need to remember. These SUAT equations are only valid when the acceleration is constant or uniform. Okay, so we need to remember that if this condition is not true, we can't use those equations. Okay. I will give an example how we can use this equation to solve this problem. So in this problem, what they have said, an object is sliding from a certain rest position, an object slides 1 meter during first seconds. Okay, the distance traveled, distance will be of what distance will object slide during the next second. Okay, so from this scenario, what we can get, they have given you the distance. Usually for using SUAT equation, you just need to remember that. Let's see what are the values or what are the scenarios they have given. So if I make a table of all the important variables, okay, so displacement is given 1 meter, while the initial velocity was 0 because it was starting from a rest. Okay, and in first second they have said the time is also 1. Now acceleration is something that we don't know, let it be A. And what is the velocity after 1 second? That is something also we don't know. So I can figure out the acceleration. If it is in constant motion, there will be a constant acceleration. So the only things that are unknown, if I let's say I'm not interested in velocity, I can use this equation, S is equal to UT plus half AT square. The displacement will be 1, initial speed will be 0, so this is 0, this is half, and the acceleration and the time taken is 1 second. So you will see that from this equation, acceleration you will get 2 meter per second square. Now if this is the acceleration, how that will help us to find what will be the distance traveled in the next 1 second. So in next 1 second, it means that total time from the initial position to the final position will be 2 seconds, correct? So what I need to find is the first total distance. I can figure out the total distance by using same equation, S is equal to UT plus half AT square. In this scenario, I'm taking from A to C. Okay, let this be from A to B, and this point is B. So A to B is 1 second, and B to C is another second, like that. So if I'm trying to come from A to C, the initial speed will still be 0, but now the acceleration is 2, and the time is 2 seconds, so 2 square. So you will get S is equal to the total displacement from A to C is 4 meter, correct? And what they are trying to ask is what is the displacement from B to C, like in next 1 second. So that will be 4 minus 1, that will be 3. So 3 is the correct answer. You will see that. So this is 1 meter, while this will be 3 meters. Okay. Clear. Now we will talk about few about acceleration due to free fall problems. Now, one thing that I would like to share with you is that during acceleration of free fall, most of the time we have to look for a condition where they say air resistance is negligible. Now, this is very important condition because when the air resistance is negligible, then the kinematics of that particular object, when I say kinematic, it means all the displacement, time, initial, final velocity. Kinematics does not depends on the mass of the object, mass. Okay, so it is basically independent of mass, and so the kinematics of all the objects would be same, whether you are like making a heavy object fall or a light object fall, everybody will follow same kinematic equation, everyone will have same velocity and time. Now, one thing also we need to remember, during acceleration due to free fall, what we have is the acceleration because of gravity, and acceleration because of gravity is pointing downwards. The acceleration due to gravity is pointing downwards, so we can use that value is 9.8 meter per second. Okay, in scenarios like MCQs, you can use 10 to just to help you do the quick calculations. Okay, uh, but direction of this is downward, so we have to remember. Now, in this scenario, the boy is throwing the ball upward at a 20 meter per second as a speed, and the boy is standing on the edge of the cliff, which is at height 100 meters. So we have to predict what is the maximum height this ball went up, and then overall time it took for the ball to come down and hit the water, and what is the velocity before it hit the water, and we can draw a velocity versus time. So we can do all those things using Survived equations. So first, what we would like to do, we like to break this entire motion into entire path into two subparts, so like A to B and then B to C. And let the height that it reaches from A to B be small h. Okay, so that's the height, that's the max height. So if I'm applying the Survived equation between, so I will make a table SUVAT, and this is from A to B. This is one dimensional motion. So the maximum displacement is h, the initial speed is 20. The final speed would be at the top, at B. The final velocity will be 0. And the acceleration will be minus g, that is minus 9.8, or I can take it as 10 for this problem. And the time taken is something that we don't know. Okay, so let this be t. Now, since I don't want to find time, I just want to find what is the maximum height. I need a equation that uses all those 4 variables. So I will use this equation, v square u square plus 2as. Now this does not have a time, so that I can plug in all the values. So v is 0, initial speed is 20 because it is moving upwards, so 20 square minus 2 into 10 into s will be your h. In that case, I will get h is equal to 20 square on 20, that is 20 meters. So we have got the maximum height. So this is the max height with respect to the boy. Okay, it has went up. Then to figure out the entire time, how much time it has taken. Okay, we can calculate from A to B. We can also calculate time. Finding time is not that difficult. We can use V is equal to U plus AT. And in that case, it will be 0, 20 minus 10 into t. So time from A to B will be 20 by 10, that is 2 seconds. So we have also find the time from A to B. Now, to find the time, we can just take the time from B to C. So I can again make a table from B to C, S U V A T. The displacement here in this case from B to C would be not just 20 but 120, because it will include the height of the cliff as well. Then the initial speed is 0, which is at initial speed at B, and final velocity is something that we need to find. Acceleration will be here again, it is minus g. Now in this case the displacement is in the negative direction, so I will take the displacement is also as minus, and acceleration is also minus, so this will be minus 10 I will take, and the time, let it be some capital T. Okay, now I need to figure out two variables, so I can use for this v square u square plus 2as, and in this case we will see that v is equal to is something we can find, v square, u square is 0 plus 2 into g is 10. Okay, and so it is minus 10, and the displacement is minus 120. So you will see that v will be square root of 2 into 10 into 120. So that will be roughly around 20 times 120, that is 48.9 meter per second. Okay, and also we can figure out the time. If we know the velocity, we can use v is equal to u plus 80, and we will see that the final speed is 48.9, initial speed is 0, acceleration is, now this velocity, and then there is the acceleration. Now velocity being negative in the direction, we should remember that as well, and so this will be 10 into capital T, so T will be 48.9 upon 10, so this is approximately 4.9 seconds. So you will say that 4.9 seconds have been taken for the balls to fall, and then so total time of flight, the total time of flight will be 2 seconds that we had from A to B, and from B to C it is 4.9 seconds, so that is approximately 7 seconds. Okay, so this is 6.9 seconds, or you can take it as 7 seconds approximately, and then what we can say is that velocity of the ball hitting is something that we have found. Now how we can find the graph? The graph is, if it is velocity versus time graph, since it is starting with some 20 speed and then becoming 0 from A to B in 2 seconds, so this will be in 2 seconds, and in next 5 seconds roughly this will be reaching negative 48.9. Now you can see it is a straight line because the gradient is constant, that is g, that is acceleration due to gravity. So this is how we use SWOT equations and acceleration due to free fall problems. I hope you understood this. Thank you so much.